I'm using a lab software, so it's not 100% accurate when it shows stuff on the command line interface, but it's good enough to explain how things work. So how do things work? When I turn on this equipment, system does not forward traffic for my computers at this stage. It needs to perform this loop-free topology selection before the traffic gets opened for the computers. Otherwise, it would just go down because of the loops, and we discussed that in the previous video. So the first step in spanning tree protocol is to elect a root bridge. So one of those four switches will be elected as a root bridge, and there's a predetermined rule how it's going to happen. When the system opens the packet, so they go quickly through listening mode and they begin to exchange BPDU packets. Bridge Protocol Data Unit packets will carry information about each switch. So each switch introduces itself to its neighbors in those packets by providing them with their own bridge ID. Bridge ID consists of two numbers. One is so-called priority, which by default is 32768. Well, in Cisco actually implementation, it's not entirely true because Cisco uses per VLAN spanning tree protocol, so that number is going to be 32768 plus the VLAN ID. It's called System ID Extended. And in those packets, the systems will read each other's IDs, and the lowest number is going to be the winner. So if the first thing is checked is the priority, if the priority is the same on all switches, and by default it is unless I change it manually, the tiebreaker in selection will be the lowest MAC address of a switch. That forms obviously that bridge ID. So if just to show you on the command line interface real quick what it looks like, I am going to do this command, show spanning tree, and I will, at this point I have only VLAN 1 here just for simplicity, VLAN 1, and I'm going to go for a section, so pipe section and root ID, no space, pipe, or bridge ID. That's pipe is going to be like a logical OR. So for example, switch 1 was selected to be the root bridge. It is signified, this bridge is the root with this MAC address. How do I know this switch 1 has been selected to be the root bridge? Because its MAC address is here, its priority is here, and if I repeat the same command on all switches, we will see, obviously this is signified here, but we will see why the switch 1 was selected to be the root bridge. The first thing they compare in those BPDU frames that come in on those interfaces is the priority. Now priority is 32769 because it's actually 32768 plus the VLAN ID, and the VLAN 1 spanning tree instance is running here, so plus 1. So this is the first parameter compared on all of those. So let me just copy that real quick and repeat that command on all switches in my topology and switch 4. So quickly we will see that on each switch their own bridge ID is the same number because I didn't change it. It's the same. It's the default 32768 plus VLAN ID. So once this parameter is checked and it's the same on all of them, the switches look into their MAC addresses, and switch 1 MAC address is AABBCC0011, and switch 2 is the same except for this byte, it's 12, it's AABBCC0012, so that's lower on switch 1. 11, 1, 1 is lower than 1, 2, that's hexadecimal. It's lower than 1, 3 on switch 3, and it's lower than 1, 4 on switch 4. So it checks the bytes from left to right until it finds the difference, and the lowest is the winner. That's why switch 1 was selected to be the root bridge. So at this point in our topology, we have a root bridge selected, and that machine is our. So let's just mark this one as a root bridge. So our switch 1 has been selected the root bridge. Now, what are the rules to select the remaining things, which is the root ports and stuff like that? One thing to notice is that the root bridge, let's go back to our switch 1, has all ports in a designated role. Show spanning tree protocol for VLAN 1. So all ports are now designated. None of them will ever be blocked. Now, by the way, this is the lab, so please ignore the last type here, shared. It's not accurate here in this virtual software, but the remaining are fine. The role is designated, state is forwarding traffic, and the cost of the port is 100. Now, this is important to understand that switch has predefined table which translates bandwidth of the interface to a cost. Just to give you an example, if the interface is Ethernet and those switches are Ethernet, which is 10 megabits per second, the cost is 100. If the switch has a port with 100 megabits per second, the cost is 19. So the faster, the lower the cost is. When the port is 1 gigabit per second, it's 2 or 4 actually, and a 10 gigabits per second is actually cost 2. Now, that cost can be changed manually, but these are the defaults. And that cost is important because the next step in our election is to select the root ports. So let's try to do that, and maybe in the next video we'll complete the whole picture. So how does the system select the root port? The first parameter is checked. The details of actually are in this blog, and I'll just put this in the description. So the first thing that the switches, that once they realize who the root is, and they already know who the root is here, if you look at these. So this MAC address is, which is the switch 1, 11.11, is the root bridge. They know that. They need to select the closest path towards the root bridge, which is called root port. That's the port role. And the root port is basically the port that is going towards the root bridge, which is going to be the fastest. And there might be only one, there can be only one port to avoid the loops. So how does switch 2 determine the root port? It has the closest is going to be cost 100 here and 100 here. So 4/0 is 100 cost. 4/1 is 4/1 is also 100 cost. So this one of those two ports needs to be selected, the root port. The other path from switch 2 through switch 3 and here is going to be 200. So the cost is higher, 200, which is 100 here and 100, or 100 here and here. This is definitely not going to be the one. Also here the path between switch 2 and through switch 4 and switch 3 and towards switch 1 root is going to be 100, 200, 300. Obviously, this is not the best cost. So the root port is going to be one of the two ports, E4/0 or E4/1, because the cost towards the root bridge is going to be the lowest. So when the root bridge is sending BPDUs, it includes cost 0 to itself. Switch 1 adds the cost of the port towards the sender, which is 100, and now needs to determine which one it is going to be the root port. Since the cost is the same, and that's the first parameter, there must be a tiebreaker. So the second parameter used by the switch 2 is going to be in the BPDU received from switch 1, determines the cost is the same. The second parameter is going to be the MAC address, the lowest MAC address of the BPDU sender. Since we ignore these costs, 200 and 300, the bridge ID that is sending the BPDU on E4/0 and E4/1 is the same switch, the same MAC address. So if this is not a tiebreaker either, what's going to be the third step switch 2 is going to use to determine which port is the root port? And that is going to be the port ID. Actually, port priority, technically it's port priority, because port ID is actually port priority and port number. So the system sends a port ID. So if I look at the switch 2 now, it receives BPDU frames. It receives BPDU frames from two sources. So let's just look at the show spanning tree. VLAN 1 interface E4/0 detailed, and for the same information on 4.1. So it receives from switch 1 BPDU, and the port that is basically here, same command on switch 1. In fact, we'll do that without the detail, maybe here. So when switch 1, being the root bridge, is sending information towards switch 2, it has this port priority, and in case of a sender, it's the same, and port number. So this is the internal identifier of 40 and internal identifier for 1. So 17 is lower than 18, or 1718. So the packet received here, let's go back to our topology, on 40 is from 17, here is from 18. The switch 2 prefers its 17 port on switch 1 and selects this port E4/0 as the root port. Let's see that happen. So we've seen that here. This port is a root port and a forwarding traffic. The other then must be blocked. So this is the root port, RP. And the other is now alternate and in a blocking state. So that's how we select the root port. Oh, it's not very accurate. Let's just put this like that. Now we only have one path towards the root bridge. So what follows is the same process on other switches. Since I'm running out of time, I'll do that in the next video.